today's class, we're going to be talking about Cloud 101. Now, before we start with the class, let's talk about the agenda. What should you understand? What should you understand? What should you understand before the end of the class, right? What are the things that you should actually understand? My people, one thing you should know is that this journey is going to have new terminologies. There are going to be new terminologies that you need to understand. So I want you guys to understand what a hardware server is. I want you guys to understand what a data center is. I want you guys to understand what used to happen before cloud. I want you guys to understand what cloud is. I want you guys to understand what cloud computing is. I'd like you guys to understand the benefits of cloud computing. I'd like you guys to actually understand the different service delivery models, the different cloud service delivery models, different cloud service delivery models. I'd like you guys to understand who cloud providers are. Yeah, I think this is enough. So this is pretty much what I want you guys to focus on. If you understand what used to happen before cloud and how cloud computing has actually changed or transformed the IT industry in general, then that should really be good for you. Okay. Now, please, if you have any questions, make sure you actually put it on the chat. Okay. So make sure you put down your questions on the chat. I'm taking a look at the chat and I'm also going to give you guys time to ask your questions. Okay. So, like I said, thanks again for joining the class. My people, what is cloud? We are actually coming to this class today because at the end of it, we want to become cloud engineers. We want to become DevOps engineers. We want to become cloud DevOps engineers. We want to become cloud architects and all of that. Now, but before cloud, what used to happen? What caused this cloud engineering role, cloud DevOps role to actually come into existence? Now, one thing I want you all to understand is that all companies are going to have data. All companies are going to have to store data. About 90% of companies are going to own, applications. About 90% of companies are going to own applications. Now the question is, where do they host these applications? Where do they host these applications? So companies are going to own data. They are going to own applications. The question is, where do they store this data and where do they host these applications? It must not be companies. It could be you yourself, right? You guys take pictures every day, right? So ask yourself, where do you store those pictures? If you store those pictures on your phones, what happens if your phone gets missing? What happens if your phone gets broken? You will not be able to actually access that picture anymore. Now, before the coming of cloud, before cloud actually came into existence, right? Before cloud came into existence, one thing I want you guys to understand is that before cloud actually came into existence, companies had to buy hardware servers. So before cloud, right, companies that had to host applications or store data, what they had to do was they had to buy hardware servers. Does that make sense? So if a company decides that they want to start hosting applications, one thing they are going to do is that, hey, these applications need to actually run somewhere. This application data needs to be stored somewhere. And that thing they are going to use to host that application or store that data is actually going to be called the hardware server. Does that make sense? So what they were going to do is that they were going to have to purchase hardware servers. Now, what is a hardware server? What is a hardware server, guys? When we talk about a hardware server. A hardware server is nothing but a compute device, okay? A hardware server is a compute device that has memory and CPU, okay? It's a compute device that has memory and CPU. So when we talk about a hardware server, we're talking about a compute device. It can be a physical device, okay? It can be a physical device that has memory and CPU. Now, the purpose of a hardware server, is for storing data and hosting application. For storing data and hosting applications. Okay? That is simply what a hardware server is meant for. So let's go back. Before the coming of cloud, companies that had to build and host the applications, companies that had to store data, they were going to need to buy what? They were going to need to buy hardware servers. Now, a hardware server, one thing you should understand about a hardware server is the fact that a hardware server has storage capacity. It has storage capacity. Does that make sense? A hardware server has storage capacity. So, Mr. Garrel, the amount of data or the amount of applications a hardware server can be able to host is dependent on what? It's dependent on the storage capacity of that hardware server. It's dependent on the memory and the CPU of that hardware server. Does that make sense? So the amount of applications or the amount of data that a hardware server can be able to host is dependent on the storage, is dependent on the memory, as well as the CPU. That's simply what determines the amount of data or the size of applications that that hardware server can actually be able to, it can be able to host, okay? Now, think about this, guys. Let's say companies need to host so many different applications. Now, because they have to host so many different applications, what they are going to do is that they are going to need to purchase so many hardware servers, okay? So companies, if they have to host a lot of data, or if they have to host so many applications, what they have to do is that they need to actually purchase so many hardware servers. That's simply what they're going to do. Now, think about you. You are a small business. Think about you. You own a small business. And your business just started. You don't actually have enough capital. But you have hardware servers. Sorry, you have application data. And you have applications that you want to host. Guys, do you think you're going to have enough money to actually buy hardware servers? Hardware servers are very expensive, trust me. There are servers that actually are going to range from about $5,000 all the way to $500,000. That's just to make you understand how expensive hardware servers are. So majority of companies in the past, before the cloud actually came into existence, majority of companies, they could not purchase or they could not own hardware servers. Now, one other thing I want you to understand is that when companies start having hardware servers and all of these things, they need to actually build a data center. So a data center, when we talk about a data center is nothing but just a building. It's a house, okay? It's a house where you are going to actually host your hardware servers, okay? So these companies, as they had so many servers and so many IT equipments, what they had to do was they decided that they were going to actually build data centers. So companies that have hardware servers where they host the applications on those hardware servers, one thing they're going to do is that they are going to have to build data centers. And when we talk about a data center, we're simply just talking about a house that used to host hardware servers. Okay? So when we talk about data center, we're talking about a house that is used to host hardware servers. That is simply what a That is simply what a data center is. So these companies, they never only had to purchase hardware servers, they had to figure out how they were going to buy land. On that land, they had to build sophisticated data centers. They had to build sophisticated data centers. Now, what are you going to find in a data center? Now, when these people build these data centers, these buildings that they use to host their hardware servers, the first thing they are going to do in those buildings is that they are going to actually build a network. They're going to build a network, okay? So one thing they do is that when they build data centers, what they're going to do is that they need to actually build the physical network. So they need to make use of things like routers. They need to make use of things like switches. They need to make use of things like cables. There are so many network equipments that they are going to actually put in those data centers. We all know that without a network, you guys will not be able to connect to this Zoom call today. Is that true? Even your houses have networks. So in those data centers, the first thing they were going to do is that they were going to have to do what? They were going to have to host the network. That network is simply what is going to give those devices the ability to communicate. Now look at what happens, Choice. Now when they build the network in the data center, the next thing they were going to do is they were going to now host those hardware servers. Does that make sense? So they were going to host the hardware server. A hardware server needs to be connected to a network. Does that make sense? Because if the hardware server is not connected to the network, then it's not going to have internet, right? So what they do is that they are now going to host the hardware servers in the network. Think about the hardware server to be your computer. I think about the network to be your switch in your house or a router in your house you're using that gives you internet. So it's the same thing. So they were going to actually host the hardware server. That hardware server is just a physical device, okay? It's a physical device that is actually plugged to a network, okay? A physical device that has compute capacity and it is plugged to a network. So the hardware servers were going to be plugged onto a network. So we are now talking about the components of a data center. We're talking about the components of a data center. So in the past, before the cloud came about, if a company needs to host applications, store IT data, one thing they were going to do is they were going to have to build data centers. In those data centers, they were now going to host hardware servers inside of them. A data center is nothing but a building that is used to host hardware servers. It's just a house for hosting hardware servers. Now, inside of that data center, like we said, the first thing they were going to do is they were going to actually build a network. When they build the network, upon that network, they were going to do what? They were now going to host the hardware servers inside of that network. Now, the next thing that these companies were going to do, remember guys, what does a hardware server have? A hardware server is going to have compute and memory. Do you guys know that your laptops have compute and memory? The amount of applications that can run on your laptop at a particular time is dependent on that. Your laptops have what? They have compute, they have memory. A laptop is just compared to a hardware server. Okay? It's not different. Maybe just because hardware servers are larger. But every compute device, everything that is considered to be a compute device is going to have memory, it is going to have CPU, and it's going to have what? It's going to have storage. Think about your phones. Your phones have memory. Your phones have CPU. Your phones have storage. Guys, is that true? Your computers have memory. Your computers have CPU. And your computers have storage. It's the same thing. So, these hardware servers that they actually host in these data centers are going to have what? They are going to have memory. They are going to have CPU. And they are going to have what? They are going to have storage. Now, one thing that these companies were going to do is upon or inside of these hardware servers, one thing they were going to do is they were going to install something called a hypervisor software. So what we are saying, Joyce, is the company actually buys hardware server, right? Now, inside of the hardware server, one thing they were going to do is they were going to install a certain software known as what? Known as a hypervisor software. So they were going to install hypervisor software inside of this hardware server. Now, Mancho, it's just like you installed Zoom on your laptop, right? Zoom is a software that you've installed on your laptop, right? Now, these people, what they do is that when they buy these hardware servers, which they're going to use to host applications and store application data, one thing they're going to do is that upon that hardware server, they are going to install something called what? A hypervisor software. Now, you might be asking yourself, what is the purpose of a hypervisor? Why should they install hypervisor softwares inside of the hardware servers? Now, look at something. Carl, the reason why they have hypervisor softwares installed into their hardware servers is because they want to be able to create virtual machines. So a hypervisor software is a software that gives a computer or a hardware server. It's a software that gives a computer or a hardware server the ability to create virtual machines. That is simply what a hypervisor software is. Guys, if you install a hypervisor software on your laptops right now, one thing your laptop is going to be able to do is that your laptop is going to be able to have virtual machines. You'll be able to create virtual machines inside of your laptop. I'm going to explain to you guys what a virtual machine is, but please just write this down. So a hypervisor software is a software that gives a computer, okay? It's a software that gives a computer or a hardware server that ability to create virtual machines. So it gives the computer or hardware server the ability to carry out virtualization. It gives that computer the ability to carry out something called virtualization. Okay, so that process of actually creating virtual machines, is called virtualization. So when you create virtual machines now on this your hardware server, that process is called what? Virtualization. And the reason why you're able to create virtual machines on your hardware server, it is because you have what? You have a hypervisor software installed on it. Does that make sense, Roland? So the reason why you're creating or you're able to create virtual machines on a hardware server is because that hardware server has what? It has a hypervisor software installed in it. So you see, this is pretty much what companies had to do in the past. They had to build data centers. In the data centers, they had to install network. Inside of the data centers now, they were going to buy hardware servers. Those hardware servers are pretty much what they were going to use to host their applications or the application data. Now, Mr. Roland, the hardware servers, they were going to install something called what? Hypervisor softwares. Now, the hypervisor software that they install inside of the hardware server, it now gives that server the ability to host what? To host virtual machines. Okay? Virtual computers. Now, guys, what is a virtual computer? What is a virtual computer? Now, a virtual computer, right? A virtual computer or a virtual machine, a virtual computer, or a virtual machine. We talk about a virtual computer or a virtual machine. In short form, they call it VMs. Okay, so in short form, you're going to hear them call it what? They're going to call it VMs. VMs, right? A virtual computer or a VM is a computer. It's a computer that is built on a hardware server. It's a computer that is built on a hardware server. Now, when we talk about a virtual computer, right? A virtual computer is a computer that you cannot touch. You can only access over the internet. When we talk about a virtual computer, right? A virtual computer is one that you cannot touch, right? It is not physical, guys. It is not physical. Okay? It's not a physical computer. It's a computer that you can only see. You cannot touch it. Okay? You can only see and access it, but you cannot touch it. Okay? It is not physical. It is created on hardware servers. Okay? That is simply what a virtual computer is. Now, why do you need a virtual computer? Why do these people not just host the application and the application data inside of the hardware server without having to host virtual computers? Now, the reason why they did that is just so that they can be able to separate data from each other. The reason why they did that is just so that they can be able to separate application A from application B. So let's say, for example, you need to host two applications, application A and application B. Guys, do you think it's advisable for you to just host everything on the bare hardware server like that? No. It's advisable that you have a virtual machine created on the hardware server, which is going to be used for hosting application A, and another one which can be used for hosting application B. So one thing these companies were going to do is that upon the hardware server, or in the hardware server, they were going to create something called virtual machines, virtual computers, like this. They were going to create virtual computers. They were going to create virtual computers, VMs, right? They were going to create virtual computers. So this is a virtual computer, a VM. So they're going to create virtual computers. That's what happens. Guys, this VM, what do you need to be able to create a VM? Now, guys, these VMs were going to have what? The VMs were going to have operating systems. Okay, one thing you should know is that every compute device has an operating system. So one thing these companies were going to do is that when they create a VM, a VM is always going to come in with an operating system. Okay, the operating system is the core of every compute device. Your phones have operating systems, guys. Your laptops have operating systems. Every compute device has an operating system. So one thing they do is that when they are to host a virtual machine, the first thing they need to choose is the operating system. When we talk about the operating system, is it Linux? Which kind of operating system do you want to host? Do you want to host a Linux operating system? Do we want to host a Windows operating system? So they were going to actually, when they want to actually build the virtual machine or create a virtual machine on the hardware server, they are going to need to choose what? They're going to need to choose the operating system which they will use for that virtual machine. Does that make sense? Well, so the virtual machine is going to have an operating system. What is an operating system, guys? That's the next thing we're going to cover after we do the Cloud 101, right? Now, but let's just talk about an operating system. The operating system is the core of every compute device. Write that down. The operating system, or an operating system, I'm writing over here on the left-hand side. An operating system, an OS, that's a short form. OS, operating system. An operating system is the core of every compute device. Now, do you guys know why you're able to see me type? You see, I'm actually just clicking some letters here on my computer, and it's actually populating here on my screen. Guys, The operating system is pretty much what does that. The computer only understands ones and zeros. A computer, right, only understands ones and zeros. The operating system acts as a middleman between the computer hardware and the computer software. The operating system is the middleman between the computer hardware and the computer software. Okay? So an operating system is a middleman between a computer hardware and a computer software. What does that mean, guys? That just simply means that the operating system is going to control memory and CPU, right? Is what controls memory and CPU on our computer. That's the duty of the operating system. It's going to control all activities happening within our computer. It controls the memory, it controls the CPU. The operating system is pretty much what is going to control the amount of storage that is allocated to a particular application on our computer and all those things. So the operating system is very important. It is the core of every computer device. Without the operating system, our computer devices cannot work. That is why for our laptops, we have operating systems like Windows, we have operating systems like Linux, we have operating systems like Mac OS. Those are examples of operating systems. Windows, Linux, Mac OS. For our phones, we have operating systems like Android. We have operating systems like what? I think it's iOS, right? Those are operating systems. Without an operating system, your computer cannot work. So one thing that happens is that as you host a virtual machine on a hardware server, that virtual machine is going to have an operating system. Does that make sense? The virtual machine is going to have an operating system. Now, one other thing I want you guys to see, take a look at something, guys. Take a look at something. This hardware server is pretty much where the virtual machines are being provisioned. The virtual machines are provisioned inside of the hardware server. Now, if this virtual machine needs to host your application, one thing that you need to do is the virtual machines need to be allocated what? Memory and CPU. Is that true? If the virtual machines need to host your application, if they need to host application data, they need to be allocated what? Memory and CPU. So what happens is the hypervisor gives us that ability to be able to allocate some of the memory from our hardware server. It can allocate some memory from the hardware server to the virtual machine. It can be able to take some of the CPU from the hardware server and allocate that CPU to the virtual machine. So that's simply what it's going to do. It's going to take some memory and some CPU based on what you define, and it is going to allocate it to that VM. Just like that. Are you guys seeing what's happening? That's simply what's happening. Now, you see that the virtual machine is completely dependent on the hardware server. It is completely dependent on the hardware server. Some of the memory and CPU from the hardware server is being allocated to the virtual machine. Now, one thing I want you guys to understand is that that memory and that CPU that is allocated to that virtual machine, the memory that is allocated from the hardware server to the virtual machine is going to be called VRAM. VRAM. So memory allocated from a hardware server to a virtual machine is called virtual RAM, which is called VRAM. Now, CPU that is allocated from the hardware server to the virtual machine is going to be called what, guys? It's going to be called vCPU, virtual CPU. So you now see that your hardware server is solely dependent on what? Sorry, your virtual machines, they are solely dependent on the hardware server. The amount of memory and CPU that can be allocated to your virtual machine It's coming from where? It's coming from the physical memory and CPU of your hardware server. Does that make sense, Joyce? Do you guys understand? That's simply what is happening. So virtual machines are hosted on the hardware server. Now, Mancho, one thing you should know is that these virtual machines that are created are isolated from each other. They are isolated from each other. Does that make sense? They have their own memory, they have their own CPU, they have their own operating system. They are isolated from each other. Now, guys, we are talking about what? We're talking about the components of a data center. We know that in the past, before the cloud came about, companies had to own their own data center. Data center was a building where they are going to host their hardware servers. They buy these hardware servers. They connect the hardware servers to the network of the data center. In the hardware server, they install what? The hypervisor software. The hypervisor software gives these servers the ability to carry out what? Virtualization. Virtualization is a process of hosting or producing virtual machines on a hardware server. These virtual machines are going to have what? The first thing, when you have to create a virtual machine, you have to choose the operating system. Which kind of operating system is going to host, is that virtual machine going to be hosted on? Does that make sense, guys? Now, we are still at the level of the virtual machine. Now, when the virtual machine is created with the operating system, the next thing you're going to realize is that it is going to be allocated VRAM and vCPU. Is that true, Richard? It's going to be allocated VRAM and vCPU. Now, one other thing you're going to find inside of the virtual machine is the runtime. The runtime. So in a virtual machine, you're going to have what, guys? You're going to have the runtime. Okay? You're going to have the runtime. The runtime. So the virtual machine is going to have what? Is going to have the runtime. Now, what is a runtime? What is a runtime, guys? Let's talk about it. Let's talk about what a runtime is. One thing you're going to come to realize is that when you have to host an application on a virtual machine, when an application needs to be hosted on a virtual machine, when an application needs to be hosted on a computer, that computer needs to have the dependencies that the application needs to be able to run. Manchu, does that make sense? So let's say, for example, you want to host an application on your computer, okay? There are certain dependencies that the application needs to be able to run on that your computer. Does that make sense? So if you need to host an application inside of this virtual machine, that application is going to need its runtime to be installed on the virtual machine. That runtime is what gives that application the ability to run inside of that virtual machine. Now, I'm going to teach you guys Software 101 in the future, I think next week or this week. And one thing you're going to realize is that every application is built from what? Every application is built from a programming language. So, for example, a company wants to start building an application, let's say WhatsApp. They are going to use a programming language to actually develop the application. They can use Java, they can use C++, they can use C#, they can use Python. So what is going to happen is that, guys, that application, before it can run on a server, the application must have what? The application's dependencies must be installed on that server. So in a virtual machine, the purpose of this virtual machine was because companies were going to host their applications inside of it. So if they have to host the application inside of the virtual machine, what do they need to do? They need to install the runtime in the virtual machine. So when they installed the runtime in the virtual machine, now they were going to be able to deploy their applications, and they were going to be able to have their applications and their application data deployed inside of the virtual machines. Are you seeing? That is simply the entire structure of a data center. That is the entire structure of the data center. So you see, they're going to have the network that is installed in the data center. Now they now buy their hardware servers, right? Anastasia, are you understanding? Are you guys understanding what we're doing here? If you have any questions, let me know, okay? So I'm simply just trying to tell you guys what used to happen before cloud actually came into existence. Does that make sense? So companies, this is what they had to do. They had to manage all of this, right, Champi? They had to manage all of this. They had to build their data center, install their physical network. Now they're going to buy hardware servers, which were very expensive. They're going to configure those hardware servers by doing what? They configure the hardware servers by installing hypervisor softwares inside of them. These hypervisor softwares were going to give these hardware servers the ability to carry out virtualization. Now, virtualization is the process or the ability to be able to create virtual machines, virtual computers on a hardware server. These virtual machines are pretty much where you are actually going to host those applications. Now, the virtual machines, for you to create a virtual machine, what do you need, Florence? You need an operating system, okay? So you need to choose the operating system you're going to use for that virtual machine. Inside of the virtual machine, what are they going to have, Belka? They're going to have the runtime, right? The runtime is simply just the dependency that the application is going to need to be able to run on that virtual machine. Now, when they have the runtime installed inside of the virtual machine, what are they going to have now? They can now be able to deploy their application and the application data. You see, this is the entire structure of a data center. So let's look at what happens. Let's look at what happens, guys. I'm going to clear some stuff here. Okay, now look at something. Guys, imagine yourself, you are a business owner, right? And the goal of your business, let's say you actually deal with makeup products. You deal with makeup products. Or let's say you deal with spare parts. Your business is growing so big in such a way that people from different parts of the world are purchasing, they are trying to buy your spare parts, they are trying to buy your makeup products. Now in the past, what you are going to do is that you're going to have to buy a hardware server because you have to host an application which people can use to be able to maybe buy your spare parts, or they can use the application to purchase what? Your makeup products. So you have to build a website. Is that true, Richard? Now that website is an application. Where is it hosted? It needs to be hosted on a virtual machine. But the virtual machine cannot exist without what? Without a hardware server. So you need to buy a hardware server. You need to pay somebody to configure the hardware server for you. You need to pay them to manage the network for you. You need to pay them to install and manage the hypervisor inside of the hardware server. You need to actually now hire system engineers. The system engineers are going to be the ones who are going to actually build the virtual machines on those hardware servers. They're going to build the virtual machines. They're going to configure those virtual machines. Now, you need to hire software developers who are going to do what? Who are going to actually host, they're going to actually build the application. The application that has to be hosted on the virtual machines has to be built by software developers. So now let's say, for example, the application is getting too big, right? It's getting too big, and you're getting more requests, more demand. Application data, there is a lot coming in. You have to store all of that. So if this hardware server gets full, what do you need to do, guys? You need to purchase more hardware. You purchase more hardware servers, you come and configure it. Are you seeing the amount of things companies used to do, Boris? So as a business, you are going to manage the entire one, the entire data center. Now let's think about this. Let's think about the physical environment where that data center is. You need to take care of the land, right? Maybe you're renting the land, or let's say you actually bought the land. You need to hire security guards, right? You need to hire security guards to do what? To secure these data centers, right? because you don't want people to just come in where they are not authorized to, and maybe they come and start stealing hardware servers, and those servers may actually have data inside of it. Does that make sense? So you see, those are the amount of things that people had to do. Think about you trying to start your business. You don't even have up to $20,000 to start, right? And then you need to be managing something that is going to cost you about $500,000. Are you seeing? This is very expensive, guys. To host a data center is not easy. Companies spend $500,000. Some companies spend $1 million. And now, one other thing you're going to think about is, Roland, imagine that this data center catches fire. Imagine it catches fire. It means you're going to lose everything, right? So now you need to start thinking about buying data centers or building data centers in another region too. So that if this one goes down, what happens? It can fail over to the other one. Are you guys seeing? Those are the things that companies had to worry on. They had to think about all of this. Okay? They had to think about all of this. Now, let me give you guys time to ask your questions. I've spoken so much. I know there are a lot of questions. So I'll give you guys some time to ask, and then I'm going to carry on. I just want you guys to understand what used to happen before cloud. This is what used to happen. Companies had to build data centers, which they were going to host what? They were going to host their hardware servers. In those hardware servers, they were going to install hypervisor software that gave them the ability to create what? Virtual machines. The virtual machines were going to be used for hosting the application itself, right? Companies had to take care from the network. So they had to take care from this network itself all the way to where? All the way to the application data. They had to manage and take care of all of this. Guys, is this not going to be difficult? Imagine the data centers goes down. You have to figure out what to do. Are you guys seeing how difficult it was? So that is a concept. This is simply what IT is built on. This is what IT is built on. This is what IT is built on. You cannot house an application is always hosted on a server, whether you like it or not. It's either you're seeing that server or you're not seeing it. But the application is hosted where? On a server. So I want you guys to draw this diagram nicely and put it somewhere. Okay? Draw this diagram nicely and put it somewhere. All right. If you have any question, please just raise up your hand, and I'm going to give you the chance to ask. So, any questions, guys? Let's talk about. I know you guys have a lot of questions. What is the difference between memory and storage? Storage, one thing you should understand about storage is pretty much where data is actually being, storage is pretty much where data is being kept. Okay? Storage is simply where data is being kept. This data at the level of your storage is going to be at rest. Okay? Storage is simply where data is being kept. That is why the amount of data you can have on a system or on a server is dependent on the storage. Okay? The amount of data, the size of data you can have on a storage is dependent on what? The amount of data you can have on a system, it is dependent on the size of that storage. Now, what is RAM? What is memory? Every system has a memory. Now, the purpose of RAM is just so that you can be able to access data quickly. Any data that is available at the level of your RAM, any data available at the level of your RAM is just so that you can be able to retrieve that data quickly. Okay? The way the computer actually works is that you simply have your RAM, that's your storage. You have your processes. So you have your RAM, you have your CPU, and then you have your storage. That's how a computer is, right? You have your RAM, your CPU, and your storage. Now, data at rest is going to be inside of this storage. Now, what happens is that when you have people who are trying to access data and all of that, When the traffic hits your computer, when somebody sends in a request to access something, it first of all checks that data at the level of the RAM, because the RAM is simply just used to quickly access data. Okay, RAM is simply just used for temporal access or easy access to data. So when you have data at the level of your RAM, it is very easy to access it. That is why sometimes, that's why sometimes when you have so many things that open on your computer, if your computer does not have a very good memory size, that might actually limit the time it's going to take for you to actually be able to access that data, because there's some data that you can have always kept at the level of your RAM so that you can actually you can easily access that data. Okay, that's simply what it is. When you go for the computer one-on-one class, they should explain this better to you, and you're going to know what RAM is and what CPU is and what storage is. Yeah, so guys, you see, this is simply what used to happen before cloud, right? So we can actually tell ourselves that we understand what a hardware server is, and we understand what a data center is, right? Now, let's look at what used to happen. Let's look at what happened. Majority of companies were complaining. Majority of companies were complaining. They were tired of having to manage an entire data center architecture. They found it difficult managing everything. They had a lot of issues. There were so many shortcomings. Okay? So there were so many shortcomings, right? Now, a group of organizations decided that they could actually take it upon themselves. Okay, so let's write this down. A group of organizations decided that they were going to host. A group of organizations decided that they were going to host data centers. They were going to host data centers in different parts of the world. And in these data centers, they were going to host IT services. Okay. So because of the complaints and because of the shortcomings with having to own data centers and manage these data centers by yourself, some group of organizations, guys, they decided that they were going to host data centers in different parts of the world. And on top, or on these data centers, or in these data centers, they were going to host what? They were going to host IT services. Now, they decided that these data centers were going to be managed by them. So these data centers were going to be managed by them. So they decided that they were going to manage these data centers. That's, they were going to actually be the ones to buy and manage the hardware servers, take care of the data centers, take care of everything that has to do with the data centers. They decided that they were going to take care of all of that. Does that make sense? They decided that they were going to handle all of that. Now, they decided that they were going to provide these IT services to people over the internet. So they decided that they were going to provide these IT services to people over the internet. Now, people could use these IT services to host their applications. They were going to use these IT services to host their applications and to store their application data. Okay, so they decided that they were going to actually make use of these IT services to host their applications and store their application data. That is simply what this group of organizations decided. So They said they were going to take care of everything, and they were going to host what? They were going to host IT services on those data centers. Now, these IT services now were going to be provided to people over the internet. Okay? Now, guys, who are these people? Who are these organizations that are deciding to actually host data centers in different parts of the world? Who are these organizations that are deciding that they were actually going to do what? They are actually going to host IT services on top of these data centers. Who are these organizations that are deciding that they are going to provide these IT services to people over the internet? These organizations were actually called cloud providers, or these organizations are called cloud providers. These organizations are called cloud providers. So they are called cloud providers. Okay, they are actually called cloud providers. So when we talk about a cloud provider is just an organization or a company that provides IT services to people over the internet. Does that make sense, Choice? When we talk about a cloud provider, right? A cloud provider is just some company that is providing what? Is providing IT services to people over the internet. Now, what are these IT services used for? These IT services are now used by the clients to be able to host their applications or store their data without necessarily having to own hardware servers anymore. Does that make sense, Mancho? So look at something, brother. Right now, instead of having to own hardware servers, instead of having to manage hardware servers, what you can do is that you can be seated in your house somewhere around the world, and with internet connection, you can be able to do what? You can now be able to access an IT service over the internet. You can access an IT service over the internet, and you can now be able to use that IT service to host your application or store your application data without having to necessarily do what? Without having to necessarily own this entire data center or own hardware server. Does that make sense? So these organizations called cloud providers are going to actually be the ones to own the entire data center, buy the hardware servers, manage the hardware servers, manage the data centers. Now, in these data centers, on the servers that they create, they are going to host something called what? Services, IT services. Okay? Now, you as a customer, you can be able to use that IT service to host your applications or store your application data without having to necessarily own what? Without having to necessarily own hardware servers or without having to necessarily own data centers anymore. Does that make sense? That is simply what cloud is. So when they talk about cloud, what is cloud? What is cloud? Cloud just simply means cloud, right? Means that someone is offering, cloud simply means someone is offering a service to you over the internet. Someone is offering a service to you over the internet. Okay? Now, I'm not done with that definition. Someone is offering a service to you over the internet. This helps you to store data or host applications. This helps you to store data or host applications without necessarily having to own what? Without necessarily having to own hardware servers. So this helps you to store data or host your applications without having to necessarily own hardware servers. We know how expensive hardware servers were. A group of organizations now decided that the complaints that people have been laying, the problems people have been facing. Now, we have a lot of money. We, the organizations, we have a lot of money. So why don't we build data centers in different parts of the world, manage those data centers, build services in those data centers, IT services. Now, why don't we provide these IT services to people over the internet? Does that make sense, Mancho? So these people can be able to use these services over the internet. They can use these services to store their data. They can use these services to host their applications. Let's say, for example, guys, an example of a service that you guys use every day is Google Drive. You guys use Google Drive, right? Or iCloud to store your pictures or to store your data, right? That is simply what a cloud service is. That's an example of a cloud service, right? You are simply using it to store your data, but the hardware server where that data is being stored, is it being managed by you guys? No, it's not being managed by you. Somebody else, the person who is providing that service to you, is managing it, right? That is simply what cloud is. When we talk about cloud, it simply means somebody is giving you access to his computer over the internet. You are using that computer over the internet to do what? To host your applications or store your data. Roland, does that make sense? That is what cloud is. So that with the coming of cloud, you can see that, Mr. Roland, you don't need to own data centers anymore, right? A trusted partner, a trusted organization called a cloud provider, right, is taking upon himself to manage data centers. He builds data centers in different parts of the world. On those data centers, he does what? He's going to build services, right? And now he's providing those services to you over the internet. And you can now be able to use that service to do the same thing that you had to do in the past, right? Because the only thing companies want to do with this is to do what? To store their data or host their applications. But now with that same IT service, what are you doing? You're using it to either host your applications or store your data without having to necessarily own hardware servers or without having to necessarily own data centers, which is very expensive to manage. Does that make sense? That is the concept behind cloud. So now, Mr. Carl, what is cloud computing? When we talk about cloud computing, right? Cloud computing is the on-demand sale, okay? It is the on-demand sale of IT services. It is the on-demand sale of IT services over the internet, okay? It is the on-demand sale of IT services over the internet with a pay-as-you-go model. With a pay-as-you-go model. Okay? Now, we're talking about these cloud providers actually having to own data centers and building services on those data centers. And we said that they actually provide these services over the internet. And what they do is that they sell these services, okay? They sell the services. What do you mean by they sell the services? It means that if you need to make use of that service, you're going to be charged for it. Using the services, it's okay using the services, but as you're using the services, you're going to be charged as you use it. So when we talk about cloud computing, right, one thing you should understand is that there's IT services that cloud providers are going to be providing to you. These services are going to be, you're going to be charged with a pay-as-you-go basis. When we talk about pay-as-you-go, it means that you're only being charged for what you use, okay? When we talk about pay-as-you-go, okay, we simply mean that with these cloud services, right, you are being charged for what you use. You're being charged for what you use. So if you do not use something, you're not being charged for it. Does that make sense? So these cloud providers are providing these services with a pay-as-you-go model. It's a pay-as-you-go model. Now, my people, Take a look at something. Take a look at something. Now, you actually have, we're talking about IT services, right? Which kind of IT services are these people going to provide? Which kind of IT services? Which kind of IT services are they going to provide? Now, they are going to provide services like compute. They're going to provide services like compute. They're going to provide services like networking. They're going to provide services like storage. They're going to provide services like databases. There are so many different services that they're going to provide. Database services. They're going to provide IoT services. They're going to provide data analytics services, etc. These are examples of IT services which are being provided by these organizations. Which organizations are we talking about, guys? We're talking about cloud providers. We're talking about cloud providers. So cloud providers, right? They are going to be providing IT services. So cloud providers are going to be providing IT services to us. They'll be providing IT services to customers over the internet, right? These are those organizations that took it upon themselves to build data centers in different parts of the world. And in those data centers, they actually had to deploy services on the hardware servers. And they are now providing those services to people over the internet, right? And people are now using those services and they are paying for what they use. They're using the services to host their applications. They're using the services to store their data. They're using the services for different purposes. Does that make sense, Carl? That is simply what a cloud provider is going to be doing. Now, look at something. One thing you need to understand is, what are some of the cloud providers that we actually have out there, right? So what are some, who are some of the cloud providers, right? Who are the top cloud providers? Who are the top cloud providers, right? Who are the top cloud providers? Now we have cloud providers like AWS. AWS is the largest cloud provider, okay? We have cloud providers like AWS, and AWS stands for what? AWS stands for Amazon Web Service. So if you leave from class today and somebody asks you, what are you doing? You're saying that I am doing AWS. What does AWS mean? AWS means Amazon Web Service. And AWS is a cloud provider. AWS is a cloud provider. As a cloud provider, what do? They provide IT services to customers over the internet. So they own a cloud platform, right? They own a cloud platform. Owning a cloud platform simply means that they have built different services, and they are providing these services to customers over the internet with a pay-as-you-go model. Does that make sense? So AWS is a cloud provider, okay? A cloud provider simply means they're providing IT services to people over the internet, and these people are us, right? We are the people using these services. Companies are using those services to store their data. They are using those services to host their applications, okay? Now, AWS is actually owned by Amazon. Amazon is a company that owns AWS. So AWS is a subsidiary of Amazon. Okay enough, I've actually been in AWS for over 2 years now. I work in AWS as a cloud infrastructure architect. I was hired in AWS, I think in 2021. And in AWS, I work as a cloud infrastructure architect. And I work with different customers. Currently, I'm working with a customer called Netflix. So we're helping Netflix to kind of like manage their cloud infrastructure and all those things. So I'm very happy that I've had the chance to work in AWS. I have learned a lot, and that's pretty much why I'm going to be using that experience that I've learned to actually share with you guys and make sure that you get yourselves up to speed and everything. I want you guys to understand that a few years ago, I never knew how to use a computer. A few years ago, if they told me I was going to do IT, I was going to say no. But now I can proudly say that I am making over $300,000 working as a cloud engineer or as a cloud architect in a year, doing one job. You guys have your teacher here in the class, Cedric. Cedric too is working as a cloud engineer and an architect, and he's making a lot of money. I'm not going to tell you guys how much he makes. He's going to tell you guys himself at the end of the class. So what I'm just simply trying to say is I'm encouraging you guys to take this very serious. Okay, there are people who started. There was this lady in class. There's a lady in class here whose friend was in my last 2 batches, and he advised her to join, but she denied. And some few weeks ago, the guy got a job. The lady texted me now and asked me that when is the next class starting. She's smiling in class. So what I'm simply saying is, you can be with somebody today. You guys are doing homework together, or you guys are working in maybe a store or something, and there's somebody, the person does like a 2 weeks, a 3 months course or a 4 months course, and it transforms his life forever. There are people from Africa who are traveling now from Africa to Europe. They're traveling from Africa to Canada because they're getting cloud and DevOps jobs. So I want you guys to take this seriously. But remember, good money does not come easy. So if you're not ready to work hard, you're not going to actually make the money. Now, guys, like we said, AWS is a cloud provider. It is owned by Amazon. AWS actually started in 2006. So AWS started in 2006, okay? AWS started in 2006. And in 2006, AWS actually created their first service, okay? AWS created their first service in 2006. And the first service they actually created was a service called SQS, okay? So AWS now is considered to be the largest cloud provider. They are considered to be the largest cloud provider, okay? They are considered to be the largest cloud provider. And the reason why they are considered to be the largest cloud provider, it is based on the number of services that they have. It is based on the number of services that they have and the number of regions. We're going to talk about that in the future, okay? So the reason why they are considered to be one of the largest cloud providers is based on the number of services that they have and the number of regions that they have, okay? Now, AWS has over about 200 services, okay? They have over about 200 services. They have over about 200 services. Over about 200 services. Now, one other provider you're going to hear about is actually a cloud provider called Azure, and it is owned by Microsoft. It is owned by Microsoft. Microsoft is pretty much it's really becoming big, and maybe this class I'm going to teach you guys a little bit of Azure almost towards the end. Or maybe during our interview prep, we're going to touch on some key aspects on Azure, because it's really many companies are looking for Azure engineers. So I'll try to see how I can be able to teach you guys a little bit of Azure. Now, the other cloud provider you're going to hear about is GCP. GCP is actually Google Cloud Platform, okay? Google Cloud Platform. Google Cloud Platform. And it is owned by Google. So I have been opportune to work with the GCP platform, and majority of my experience has actually been on AWS. So this our class is really going to be focused on the cloud part of it is going to be focused on AWS. And AWS is, like you can see it's the largest cloud provider. That's the reason why we are studying it. When you understand AWS, you can be able to now use those skills on the other cloud platforms. One other cloud provider you're going to hear about is a cloud provider called Alibaba, right? So there's a cloud provider called Alibaba Cloud. I think it's in Asia. I think it's owned by an Asian or something. So you have another cloud called Alibaba, and pretty much they do have different cloud services. So those are the different kinds of cloud providers. Now, Manjo, we've been talking so much about a service, cloud service. What is a cloud service? We know that a cloud service is an IT service, right? But what is it? What is it used for? Right? What is a cloud service? All right, so let's say that a cloud service is an IT service, right? Cloud service is an IT service, but that's not enough, right? So what does that mean? What does that mean? Now, my people, when we talk about a cloud service is an application actually. A cloud service is an application designed by a cloud provider. Okay? A cloud service is an application designed by a cloud provider designed by the cloud provider. Let's put a full stop. Now, it is provided to customers. It is provided to customers over the internet. It is provided to customers over the internet. It is provided to customers over the internet so that they could use the service to carry out a particular task. Okay, so cloud providers are actually making use of this cloud. Cloud providers are providing cloud services. A cloud service, right, is an application hosted where? Hosted in the cloud provider's data center. Is that true, Roland? It's an application hosted in the cloud provider's data center, and that application is being used to carry out a particular task. It is used to carry out what? A particular task. So a service is going to be used to carry out a particular task. Now, guys, let me tell you guys something. The reason why cloud providers actually create cloud services is pretty much because customers lay complaints. So when a customer lays a complaint, what happens? A cloud provider can actually create a service that can be used to do what? That can be used to remediate that complaint. Let's say, for example, customers used to complain that they needed somewhere they could be able to store their data. What happened? Cloud provider went in and created a storage service, which now customers could use to store their data. Customers complained that they needed a service that they could use to maybe host their virtual machines. What did they do? Cloud providers went in and they created what? A compute service that they could use to create virtual machines. So what actually happens is that when customers lay complaints pertaining to certain things that are not available, what happens? The cloud provider responds by creating a service that customers can use to actually carry out that particular task. Okay, so they use that to carry out a particular task. That is what a cloud service is. That is a cloud service. Now, Mr. Roland, as companies move to the cloud, because now, majority of companies are living from their data centers, Roland. They are living from their data centers. They are moving their applications away from their data centers, right? They are moving away from their data centers. They are taking their applications to the cloud. Does that make sense? They are moving their applications to the cloud. Now, if they are moving those applications to the cloud, what do? They are going to need a cloud service that can be able to accommodate that application. That is why, right now, majority of companies, they don't need what? They don't need data centers engineers anymore. Majority of companies do not need data center engineers anymore. Data center engineers were engineers that were going to be managing companies' data centers. But now, because companies are not using data centers anymore, they are moving towards the cloud. Who do they need? They need cloud engineers and architects. Are you seeing how these roles are switching? Now, from data center engineers, from the demand of data center engineers, companies are moving what? They are moving towards what? They are moving towards cloud engineers, cloud DevOps engineers, and cloud architects. Okay? That is how they are moving towards these people. Why is it so? This is because companies are moving from on-premises. What is on-premises? When we talk about on-premises, we're talking about a company's own data center, right? A company is going to call his own data center an on-premises, right? So they are moving away from their on-premises data center. Where are they moving to? They are moving now. They are moving their applications to what? To the cloud, right? So they are moving the applications away from their on-premises data centers and they are moving it to the cloud. If they are moving these things to the cloud, it's because there is something that the cloud offers. if they are moving their data and their applications to the cloud, if they are deciding to use cloud services, it is because there is something that the cloud actually comes with. That is why the next thing we're going to be taking a look at is the benefits of cloud. Why is there a mad rush for cloud services? Why are majority of companies moving towards cloud services as compared to having to own their own hardware servers? Does that make sense? We're going to take a look at that. But now, the next thing I want us to take a look at, hope that you guys have understood this. If you have any question, please put on the chat. Cedric is going to respond to them. Okay. Manche, don't bother about SQS. We're going to talk about that later. It's just an example of a service. Now, so we're going to talk about one very important aspect, and that thing is called service delivery models. Service delivery models. Service delivery models. Now, my people, one thing you should understand is that cloud services, okay, cloud services are categorized. Cloud services are categorized. Does that make sense? Cloud services are categorized into service delivery models. Okay? Cloud services are categorized into service delivery models. Okay? They are categorized into service delivery models. Now, my people, there are three service delivery models. There are three major service delivery models. There are three major service delivery models. Now, the service delivery model, okay, the service delivery model, right? The service delivery model, I'm just going to put SDM, okay, SDM. The service delivery model, okay, SDM, the service delivery model is going to make us understand, it makes us understand to what extent is the cloud provider, going to manage the service, right? To what extent is the cloud provider going to manage the service? Now, there are three service delivery models, three measures, okay? What do we have, my people? We have IaaS, that is infrastructure as a service. We have PaaS, that is platform as a service. And we have what? We have SaaS, that is what? That is software as a service. Okay, so these are the three service delivery models. Please turn on your cameras. Respect it all, because very soon you're going to be kicked out from class, and don't feel bad. So these are the three different service delivery models that we need to understand. Now, guys, let's talk about them. For us to properly understand how these different service delivery models work, let us actually let's go back and design that data center architecture. So let me call somebody up. All right, Mancho, let me just go with you. All right, let's go back to our data center architecture, right, and talk about it. So for you to understand the service delivery models, right, you need to actually understand that architecture of the data center. Guys, what's the first thing we're going to find in the data center? What's the first thing? You guys can unmute yourselves and tell me. What's the first thing you're going to find in the data center? What's the first thing? What's the first thing you're going to find? Network. Thank you, Solomon, right? So the first thing you're going to find in the data center, like we said, is the network, right? Okay. Okay. Now, guys, what is the second thing? In the data center, the most important thing you're going to see is what? The most important thing. Most important thing in the data center, what is that? Hardware, the hardware server. Thank you, Mancho. So on the network, we now have our hardware server, right? Okay. Okay. We understand that the hardware server is going to have what, guys? The hardware server is going to have memory, is going to have CPU, is going to have storage and all of that, right? So we're going to have, it's going to have memory, it's going to have CPU, right? Memory, CPU. Okay, now inside of the hardware server, what are we going to install for virtualization? What are we going to install, guys, on the chat? The hypervisor. Thank you, guys. Thank you. So we're going to install the hypervisor, right? The hypervisor is going to be installed inside of the hardware server. So you're going to have the hypervisor. Okay. Now, since we have the hypervisor, it means that we can be able to have what now? We can be able to produce virtual machines. Is that true? The virtual machines is pretty much where our applications are going to be hosted and our application data, right? So we're going to have something like this, right? So this is our VM. Is that true, guys? This is our VM, right? So we can create VMs. And one thing you should know is that the amount of VMs you can actually create is dependent on the size of your hardware server, right, Anastasia? Remember, the VM is fully dependent or solely dependent on the hardware server, right? Now, let's talk about the VM. What are you going to have in your VM, guys? For you to create a VM, what do you need? Operating system. Wonderful, Roland. So you're going to need an operating system, right? So you're going to need an operating system, be it Windows, Linux, Mac OS, right? You need an operating system. Now, for you to be able to host your application, yeah, that's good. For you to be able to host your application, inside of that VM, you're going to need what? You're going to need a dependency, the runtime, right? You're going to need the application runtime. That is good. Now, because you have the application runtime, it means you can be able to do what? You can now be able to host your application. Guys, for you to understand AWS or for you to understand this class, make sure you always go through the class recordings. Trust me. At the end of this class, you're going to forget so many things. All right. So now, because we have the application runtime, now we can be able to do what? We can be able to host our application. So we can now have our application and we can have our application data. So you see, this is simply how it's going to look like. Okay. Now let's talk about the service delivery model. Now take a look at something, my people. The service delivery model, right, is simply helping us categorize our IT services to know to what extent the cloud provider is going to manage that IT service. Now look at something, Therese. See, at every point in time, right, the cloud provider is going to manage from this network all the way to where? All the way to the hypervisor. Keep that in mind, write that down. From the network to the hypervisor, the cloud provider is always going to manage that. Please write that down. So the cloud provider always manages, from the network to the hypervisor. He always manages that. Because he's the one building the data center. He's the one buying the hardware service. He's the one to install the hypervisor software inside of that and manage that. Now, Joyce, this is pretty much where your services are going to be built. Your services are going to be built, right, upon inside of the hardware you're going to have those cloud services. Now, Joyce, there's an extent to what the cloud provider manages and what you are going to manage when you're making use of the service, okay? So when you're making use of the cloud service, please write this down. When you are utilizing the cloud service, there is an extent to what you can manage. There's an extent to what you can manage and what the cloud provider manages. There's an extent to what you can manage and what the cloud provider. There's an extent to what you can manage and what the cloud provider manages. Now, Mancho, that is why every service falls under one of these categories. Does that make sense? because this determines what the cloud provider manages on that service and what you are going to manage. Okay, now look at something, brother. Now if that service, right, the cloud provider is managing from the network all the way to, if the cloud provider is managing, if the cloud provider is managing from the network all the way to the data, the application data. So if you're utilizing a service where everything is managed, that's from the network all the way to the application data, right? If this is the service you're utilizing, then that service is going to fall under what? It is going to fall under SaaS. Because SaaS, it's a service delivery model where the cloud provider is going to manage everything. Write that down. So the SaaS, software as a service, when you hear about SaaS, right? When they talk about SaaS, it simply means that it's a service delivery model where the cloud provider manages everything. The cloud provider manages everything. The cloud provider manages everything. Does that make sense? So from the network in the data center all the way to what? All the way to the application data, the cloud provider is going to manage all of that. Does that make sense? Now, so as a customer, Joyce, as a customer, right? As a customer, you are only going to pay for subscriptions. You pay for monthly subscriptions. So as a customer, you're only going to pay for subscriptions. You're only going to pay for subscriptions and utilize the service. You're only going to pay for subscriptions and you're going to utilize the service, right? Because the cloud provider is going to manage everything. Now, Gary, an example of a SaaS service, brother, is Netflix. Netflix is an example. Microsoft Word is a cloud service. It's an example of a SaaS. Now, when you are making use of Microsoft, Therese, do you manage anything? No. When you're making use of maybe Microsoft Outlook, or you're using Gmail, Gary, do you manage anything? No. The cloud provider manages everything, right? So that is SaaS. So you see that with SaaS, there is little or nothing to do. You just simply pay for the subscription and you're making use of it. Does that make sense, Roland? That's why you see I'm drawing this diagram. Because if I don't draw this diagram, you're not going to understand how it works. Okay? So with the SaaS, you as the customer, you don't manage anything in that service. You just simply use that service to do your stuff, right? The cloud provider takes care of everything. Does that make sense, Manjo? Now, let's go to the next one. Let's talk about IaaS. Now, Manjo, brother, see, one thing you should understand is that with IaaS, the cloud provider only manages from the network to the hypervisor. The cloud provider only manages what? He manages from the network to the hypervisor. IaaS. So the cloud provider is only going to manage from where? From the network to the hypervisor. Now that means that the customer, when utilizing that service, Therese, the customer is going to have to choose his own operating system. The customer is going to have to install his own runtime. The customer is going to have to manage his application and manage the application data. Does that make sense? So with IaaS, it's a service delivery model where you have that ability to customize. You have that ability to choose what you actually want. Does that make sense? So let's write that down. With IaaS, the cloud provider only manages from the network to the hypervisor. Now, the customer manages from the operating system all the way to what? All the way to the application, all the way to the application data, right? So Joyce, if you are trying to make use of a service, let's say you're trying to use an AWS service, right? And that AWS service, you need to be the one to choose the operating system. You need to be the one to choose the operating system. You need to be the one to actually choose the application runtime. Like you need to be the one to actually install. You need to be the one to install and manage the application runtime. Let's say you need to be the one to actually manage the application itself. So you need to be the one to manage the application and manage. You need to be the one to manage the application and application data. And that service you're making use of is actually falling under what? Is falling under IaaS. Does that make sense? So the service now is falling under IaaS. Now, what does it mean to be the one to choose and manage your own operating system? Mr. Carl, remember, brother, when you make use of a server, one thing you're going to realize is that anytime you choose an operating system, anytime you install something inside of that server, now as that thing runs, it might be open to vulnerabilities. So you as the customer, you need to be the one to actually do what? You need to be the one to ensure that you're always updating the system's operating system. So if you're using IaaS, the cloud provider is not going to do that for you, right, Carl? Because you're the one managing what? Your operating system, right? So the cloud provider is not going to do that for you. You are going to manage what? You are going to manage the operating system. So you have to ensure that you're patching the operating system. You have to make sure you're updating what? You're updating the runtime, right? If the runtime version has changed, you need to update the runtime. You have to be the one to figure out how you're going to carry out scalability, right? How are you going to scale that application that you're hosting, right? So scalability is going to be managed by you. So when you're making use of IaaS, scalability will be managed by you, right? Scalability will be managed by you. So you see, that's pretty much what infrastructure as a service is, right? It's a cloud-driven model where the cloud provider does not manage anything after the hypervisor. You, the customer, using that service, you manage from the operating system. You're going to be the one to choose and install and manage your runtime. You're going to be the one to manage your application and your application data. Well, is that clear? That's simply what the IaaS is. Now, my people, with the PaaS, look at what happens. The cloud provider is going to manage from the network all the way to what? All the way to the application runtime. Okay? So the cloud provider is going to manage from the network all the way to the application runtime. So that will be managed by the cloud provider. The cloud provider is going to manage from the network. That's the, when I talk about this network, this is the physical network, the network available in the data center itself, right? So the cloud provider is going to manage from the network all the way to where? All the way to the application runtime. So the cloud provider is going to be the one to manage the operating systems you're using. He's going to be the one to manage that. So you as a customer, what are you going to manage, guys? You as a customer, you are only going to manage the application and the application data. Let me repeat it, guys. With platform as a service, right? With platform as a service, I'm writing over here. My screen is full. My people, with platform as a service, right? PaaS. The cloud provider manages from the physical network, right? The physical network. He manages from the physical network to what? He manages from the physical network to the application runtime of your virtual machines, right? He manages to the application runtime of your virtual machines. Does that make sense, guys? The cloud provider is going to take care of that. Now, you as a customer, what are you going to manage, guys? You as a customer, you are only going to manage. You as a customer, You're only going to manage the application and the application data. Guys, does that make sense? So the operating system this time is going to be managed by the cloud provider. So it's going to make sure that the virtual machine's operating system is being patched. It's going to anything that is any failure at the level of the operating system is going to be taken care of by the cloud provider, right? The runtime is going to be managed by the cloud provider, right, Carl? So what you have to manage is just the application and the application data. Okay, so that is simply the service delivery models, the different service delivery models. So the different cloud services actually fall underneath any of these models, right? So they fall underneath any of these models. Guys, do we understand? Are you guys understanding? All right, please don't be shy, don't feel bad. If there's anything that you never understood, as soon as we're done from the class, you can reach out to me. Okay, just let me know if there's something you want me to explain. But trust me, if you go through the record again, it should make sense. Okay, so you see that cloud services actually fall where? They fall inside, they fall underneath any of these service delivery models. Okay, so that is simply what you need to understand, guys. If you understand this class of today, then you know what cloud computing is. Okay, that is cloud computing for you. That is AWS for you. We're going to be touching on different AWS services. What's the difference between the application runtime and the application? Okay, look at something, brother. I told you that an application is built from what? An application is built from codes. Developers are going to write codes. Those who develop applications are called what? They are called developers. They are going to develop the application code. They are going to build the code. They're going to build the code, and they'll now use that code to form what? They'll use the code to form the application. So an application is a combination of different software codes that have been compiled and built to form an artifact. Now, if that application needs to be deployed, deployed simply means that you want the application to live on a server. If that application needs to be deployed on that server, you need to ensure that the operating system of that server supports that application. You need to also ensure that that virtual machine where you're going to be deploying that application to, that virtual machine has what? It has dependency. It has the application dependency installed inside of it. Most of the times, right? Most of the times, the programming language that your application was built from, you need to install that programming language inside of your server. Like for example, if an application is built from Python, right? You have to ensure that that Python is installed on your virtual machine as a dependency or as a runtime. So the runtime is just the dependency that the application needs to run inside that server. Without that runtime, the application cannot be able to run on that server. Now, Gary, as people use the applications, data is being generated. Is that true? People are going to use the application, they're going to be storing data and all those things, right? They'll be generating data. Like for example, Joyce, when you're making use of WhatsApp, you're sending messages, right? You're sending people messages and all of that, right? Where do you think that is stored? That is application data. It's being stored somewhere, right? So that data has to be managed. Does that make sense? It might be managed maybe on a storage, or it might be managed in a database and all of that. But the data is simply what, as people use those applications, data has been generated. The application itself might even need data to be able to run. It might need some data. Like for example, Carl, you try to log into a website and they ask you to input your name and your password, right? When you put in that details, you wait for some time, then the system now allows you to access the application. Do you know why? Because the application takes your details and goes and check if that your information is actually true. If that information is true before it allows you now to access the system, that is application data. So all of those things are pretty much what we're talking about here. Don't bother. We're going to talk about software 101 as soon as we're done from here. As soon as we leave from here, we're going to go to software 101. And when we talk about software 101, I'm going to answer some of those questions, okay? So please don't bother. I know there are a lot of questions you have in your mind. What's a programming language? What's a code and all those things? What's a software? We're going to talk about that when we go towards that aspect of software 101, okay? So today's class was just more focused on cloud computing and some of those cloud computing concepts that you need to understand, okay? Any other questions? Can we discuss examples of IaaS? We're going to discuss that when we start the AWS class, okay? If I call some of the cloud services, it's not going to make a lot of sense to you. So when I start teaching, when I start teaching you guys the different services, I'm going to explain to you what if this service actually falls under IaaS or it falls under PaaS and all of that. Okay, so we're going to talk about that. We're done with that. An example of a PaaS service, you can think about WordPress. Those of you guys who develop websites and all of that, you can think about WordPress. When you're using WordPress, you don't need to manage the servers. You don't need to manage the runtime. You don't need to manage the runtime of the servers, right? The person providing that WordPress service to you takes care of that. He just needs to take care about what your application data. So like I said, when we start doing things, you're going to see how this actually works. So right now, just understand the concept and know what it's actually used for. Okay. I hope that you guys are done writing. I'm gonna clear off the board. Guys, next thing we're going to talk about, there are some, so I want us to talk about public cloud. I want us to talk about public cloud. I want us to talk about private cloud. Okay, I want us to talk about hybrid cloud. Public cloud, private cloud, hybrid cloud. Public cloud, private cloud, hybrid cloud. Now, Gary, when cloud services, right, are made available to anyone, right, that's public cloud. Like if a cloud provider services, right, is available for any kind of person, for anybody, right, anyone, that's public cloud. Does that make sense? Now, don't bother, I'll give you guys a chance to write. Just listen. I'll write it down on the board. Now, so we can consider that AWS is a public cloud. Why? Because AWS's services are available for anybody. Anyone who wants to use AWS, right, can make use of its services. There is no limitation to who can use what AWS services. Does that make sense? So AWS now is a public cloud because its services is available for anybody to use. Is that true? Now, GCP, Azure, those are all public cloud providers because their services are available for anybody to make use of it. You just need to go there and you create an account and you can start utilizing those services. Does that make sense, Carl? That is simply what public cloud is. Now, when we talk about private cloud simply means that the services are made available for a particular person. Okay, Joyce. So the services are made available for a particular organization. Now, the beautiful thing about AWS that you guys should know is that AWS, Microsoft, and GCP, in as much as they are public clouds, they also have some level of private cloud. Why do I say so? AWS actually has something called GovCloud. Have you guys heard about that? GovCloud. So AWS have GovCloud. And GovCloud is only for the United States government. If an organization is not from the United States government, he cannot use GovCloud. Are you seeing? That's an example of what? That's an example of a private cloud. Facebook themselves, they manage their own servers and their services are meant only for them. That can be an example of a private cloud, right? So when we talk about public cloud simply means that the services provided, right? The services, right? With public cloud, right? The cloud services provided can be used by anyone. Okay, so with public cloud, the services can be used by anyone. Now, when we talk about private cloud, what we mean is that with private cloud, the services are not made public. Okay, the services are meant for a particular organization. So the services are meant for a particular organization. Okay, the services are meant for a particular organization. Now, let's say, for example, right, Gary, a company, right, can decide to build data centers in different parts of the world or in different regions, right? And the company itself can host some services. They can host some services in those regions, right? Because cloud services are hosted in regions. I'm going to explain that to you. Okay, they can decide to build data centers in different parts of the world, and they can host services on those data centers. And now those services are going to be meant for the company itself. So that's private cloud, because the services that are there are only used by them. Does that make sense? That's private cloud, because the services there are only meant for them and nobody else, right? So when we talk about private cloud, we simply mean that the services are meant for a particular organization, right? The services are not being exposed to everybody. It's meant for a particular person. Does that make sense, guys? I hope you guys are understanding. If you don't understand the concept around cloud, you'll be very confused. You'll be very confused. But I hope that these explanations you guys are really getting it. And like I said, don't be scared. If you have any question, ask. I was not explaining this. I never knew what this was. The first time I really understood cloud was the time I actually went to teach. Like 3 years ago, when I started teaching, that was the first time I really understood cloud. Like, they told me I had to stop the class, and I was like, they said I have to go and start with IAM. I was like, how can I even go and start talking about cloud services when people don't even know what the cloud service is? And that's how I studied and really understood this concept around cloud. So that's what public cloud is. And you guys can tell me what hybrid cloud is, right? Now, when a company says they're hybrid, hybrid just simply means that they are using both private and public cloud, right? It simply means they're using both private and private cloud. For example, Joyce, a company, right, can actually have some of their applications hosted what? They can have some of the applications hosted on their own data center, right? They can have some of the applications hosted on their own data center, and they can have some of the applications hosted where? Hosted on a cloud provider's platform, maybe on AWS or on GCP or on Azure, right? So they can have some of their services on AWS. So you see that some of the applications can actually be on AWS. They might be hosting some of the applications on AWS, right? And then they might be hosting some of the applications where? On their own data center. So because of this, they can call themselves a hybrid environment, right? Because they have some of the applications on their own data center. This data center has been owned by them, and they have some of their applications hosted where? On maybe another cloud provider's platform. So they can call themselves a hybrid cloud. So when we talk about hybrid cloud just simply means that company utilizes both private and public cloud. It utilizes both private and public cloud. Okay, a company utilizes both. They utilize both public and hybrid cloud. For example, just put for example. I always love drawing diagrams because that's simply how I understand certain things, right? So like in this one, you can see that the company has some of its applications on its own data center, and then it's hosting some of its other applications in the cloud, right? So they can call themselves a hybrid cloud. So when we talk about hybrid cloud, just know that companies' applications hosted or companies' applications are hosted their own individual on-prem. We hear about on-prem, it means their own data center, right? Their applications are hosted on their own individual on-prem data center. Also on a public cloud, and also on a public cloud AWS. Okay, go ahead and ask your questions.
Oh, okay. Sorry if there's background noise, but I'm kind of confused about the hybrid cloud definition.
Yes.
Like the two definitions it gave us are kind of different things. Like one, you're saying company utilizes both private and public cloud. Then the other one speaks on a physical on-premise, like a data center, and like one on the cloud. So I guess like so I'm confused on. Yeah.
Let me explain something to you. If you remember, the time I kind of like, if you remember, I told you guys that there are some companies that can actually have their different data centers. And these companies can host certain services on their data centers, and they're going to be the only ones using those services. Now, they can consider this to be what? They can consider this to be their cloud, because they have their services that they're hosting on these their data centers. And those services are actually what? Those services are actually, or those data centers where the services are pretty much owned by them. I gave you guys an example like Facebook. I told you guys that Facebook itself has different data centers in different parts of the world. And Facebook has deployed some of its services on those data centers. And Facebook is using those services only for themselves. So they can consider that to be their private cloud, because nobody else accesses those services apart from them. Is that true? I told you guys that, right? That is private cloud. Because the services that are in there are being utilized by just a particular what? By just a particular organization. Does that make sense? Now, that is it. Now I'm taking you to private cloud, and I'm saying that so I'm taking you to hybrid cloud. I'm saying that the company utilizes both private and public. That means that I told you guys with public cloud, you are utilizing someone like AWS, you're utilizing someone like GCP, because their services are made available for everybody, right? That is public cloud, because the services you are accessing, I can also access those services, right? It's made available for anybody. So I'm accessing those services, you are accessing those services. That's public cloud. Now, I can actually have my private cloud where there are certain services where I have my services hosted, which are meant only for my organization, right? So I can have my private cloud where I have services owned only for my organization. And I can also be able to do what? I can also be able to access public cloud to utilize some of its services where everybody can also use that service. So now I can consider myself to be a hybrid cloud model, because I am hosting some of my applications on my private cloud or on my company's own data center. And then I am also making use of what? I'm also making use of a public cloud, which is maybe AWS or GCP. All right, if you have any questions, please you can ask us.
So would AWS be considered a hybrid cloud then? Because you mentioned that it has, like, it's a public cloud, but also that it has like Gov.
AWS actually has, okay, AWS has something called GovCloud, but GovCloud is only meant for the US government. So just consider them to be a public cloud, right? For now, just consider them to be a public cloud. Don't bother so much about that. Just consider them to be a public cloud. They are mostly considered to be a public cloud. But just know that a public cloud just simply means its services provided can be used by anyone. And that's simply what AWS does. That's what Azure does. That's what GCP does. With private cloud, its services are meant for a particular organization, right? For example, you, a company, you can have your data centers. In those data centers, you can build some services, and you're the only one utilizing it. So that can be your private cloud. A hybrid cloud simply means that you're using a public cloud and you're also using a private cloud. So that is simply hybrid cloud, because some of your applications are hosted on AWS, which is a public cloud, and some of your applications are hosted on your own on-premises data center. So you can consider that to be a hybrid cloud. Does that make sense? All right. Manjo, do you have a question? I saw your hand up. Do you have a question? I saw your hand up.
Oh, no, that was the same question I got.
Okay, good. Now, so that is simply what you guys should understand. And next thing I want us to talk about Next thing I would like us to talk about is let's talk about multi-cloud. Multi-cloud just simply, you guys can guess, right? Multi-cloud simply means the company can have some of its data or applications hosted on AWS, and then maybe they can have some of the other applications hosted on maybe Microsoft Azure. So they can consider to be a multi-cloud platform because they're using both AWS and they're using Azure. That can be multi-cloud, right? They have some of the applications hosted on AWS and some of the applications hosted on Azure. That's multi-cloud. We're going to talk more about that when we actually get into the course proper. You're going to realize that there are some companies that are using Azure and using AWS at the same time. They're using some Azure services and using some AWS services, so they can call themselves a hybrid cloud. Okay. So we've been able to cover some of these important aspects. The next thing I would like us to talk about is I would like us to actually talk about the benefits of cloud. Benefits of cloud. Guys, I would like you all to unmute yourselves so we can talk about these benefits. Based on what you've understood today, Anastasia, can you give me a reason why cloud is better than having to pretty much own your own data center? Can you give me one reason why you think a company will prefer making use of a cloud provider as compared to owning his own data center?
Yeah, it probably will save them time and money.
Yeah, it's going to save them time and money, right? Why do you think it's going to save them money? Why do you think with cloud, there is cost optimization? That's pretty much what they call it. Why do you think with cloud there's cost optimization?
Is it still me?
Yes.
I think you mentioned the fact that companies were complaining about the cost that they had to build, starting from the hardware, the whole data center and everything. So I think I think that's where it's more costly. So
okay. So how does the cloud help you save that cost then?
You're going to be using, maybe depending on each of them, they can actually provide a service for you. And I know you pay as you go, but then
that's what you want to say. That's just simply what I'm looking for. That's what I'm looking for. With cloud, you only pay for what you use. Right, Mancho? If you go and buy a server, you have already paid for it. Even if you're not using anything on it, you are still paying for it. You have already paid for it, right? The most important thing about cost optimization is the fact that you do not have to own data centers. You do not have to own data centers, right? Or hardware servers. With cloud, you do not have to own data centers or hardware servers. With cloud, you simply use the services. With cloud, you simply use the services provided, and you only pay for what you use, and you only pay for what you use. Now look at something. If you own your own data center, you need to actually take care of that data center. Gary, you need to buy more hardware servers, right? You need to pay for electricity. You need to pay for security guards. You need to take care of the data center engineers. You need to take care of so many things. When servers get bad, you need to actually fix them. You need to buy more servers. You need to even build other data center locations, Richard, because your data center can go down. Are you seeing the amount of things that you have to do? But with the cloud, you're only utilizing its services, right? Those services that are built on those hardware servers or on those data centers. You only use those services, and you use those services to carry out whatsoever thing you wanted to do when you were thinking about having to actually build a data center or own hardware servers. So that's simply why with cloud, it's better because you only pay for what you use and you do not have to manage hardware servers, right? That heavy lifting of buying and managing data centers, of building data centers or managing hardware servers, that heavy lifting has been taken away from you, and that burden is being handled by cloud providers. So cloud providers have taken away that burden of owning data centers or building or buying hardware servers, and they now just give you the ability to use their services and only pay for what you use, right? All right, what's the second one? Go ahead, Terence.
I imagine it would be easier for like disaster, like if there's some storm or something, or just destroy the whole data center. And on the cloud, it's already up there. So.
Okay. Can you repeat yourself? Repeat yourself. Let me hear what you wanted to say.
I said it would be better for like disaster recovery, I suppose, if you have your data centers, like you have natural disasters like earthquakes or storm or something will just destroy the whole thing. But if it's on the cloud, it will be easier to manage.
Yeah, we have better disaster recovery. It's a better disaster recovery plan. So when you're making use of the cloud, there is a better disaster recovery plan. Why is it so? Why do you think there's a better disaster recovery plan? Remember that when you are making use of cloud, you have the ability to actually host your resources in different regions. Like I told you guys that cloud providers are going to build data centers in different parts of the world, right, Uche? Consider those different parts of the world to be different regions. So Uche, you can be able to host your application here, Mom, and you can also host your application here, right? Now, if this one goes down, what happens? What happens? You can be able to switch over, right? So you see that there is a better disaster recovery plan. We're going to talk more about this as we get into the course. There's so much to talk about disaster recovery. You're going to realize that the way cloud services have been built, they are actually being built on so many different hardware servers. So even if one hardware server goes down, it does not actually affect that service. You're actually going to see that as we go into the course. But just know that with the cloud, there is a better disaster recovery plan as compared to when you're on premises. That's why some companies who still make use of on-premises, right? They use the cloud as their disaster recovery environment. So if something happens to their on-premises, they can automatically just switch over to the cloud. Okay, so we're going to explain that better as we continue with the class. Okay, go ahead.
I want to talk about the flexibility and the scalability.
Flexibility and scalability, very important. Flexibility and scalability. All right, go ahead.
Let's say, for instance, if we are using cloud and we need a lot of space for our softwares and everything we are working on, we can easily scale up what we need.
Yep.
And it's very easy to make those switches, like scale up and scale down.
Yeah, that's good. So with cloud resources, one thing you guys should know, please write this down. Cloud resources are always available. All right, Uche, there's no time when you want to go and use a cloud service and tell you that it's full. No, it's always going to be available. Okay, so cloud resources are always available, Joyce. In as much as you can pay for it, right? You can use it as you want. That's why people enjoy using cloud. Imagine, Mancho, if you're on premises, brother, you might want to go use create a server, and they tell you what? They tell you that the hardware server is full, right? But if you're in the cloud, they'll never tell you that. In as much as you can pay for it, you can just keep getting whatever thing you want, right? So the cloud treats you like a baby, where you get everything you want. But remember that you have to pay for it, right? So, like he said, in the cloud, there is scalability. Like, for example, you can be making use of a resource and you see that there is high traffic hitting that resource. It can be able to scale out to be able to accommodate traffic, and it can scale back in when traffic actually reduces. You see, we're going to talk about that. Like most of these things, we'll talk about it as we start the class. Now, That ability for you to actually have anything that you want, of that ability to actually get anything you want is considered to be elasticity. So you're going to say that the cloud is elastic. The cloud is elastic. So we're going to say the cloud is flexible. So there is flexibility, there is scalability, and there is elasticity. We're going to talk about this in the future. In the cloud, there is flexibility, scalability, and what? Elasticity. Elasticity just simply means that the resource is always available, right? Resources are always available when you need them. And when you don't need them, they're taken away, right? So that's simply what elasticity is talking about. Scalability is just simply saying that if you have a resource and there is high traffic, right, and the resource is unable to accommodate that traffic, it can be able to scale out to withstand the traffic, and when there is less traffic, it can be able to scale back in, so that you're saving on cost, boys, right? While still being able to ensure high performance for your application workloads. So we're going to talk about that in the future. Okay, good. There is better collaboration. That's good, Belcam. The fact that data is available everywhere. You just need internet. It does not matter where you are, right? It does not matter where you are. You'll be able to actually access that thing with no problem, right? You can access a cloud service anywhere you are. You just need internet, right? As you have internet, you can be able to access a cloud service no matter where you are. So that also falls under flexibility, right? Now, there is room for innovation, right? There is better innovation in the cloud. Why is it so? Why is it so? Uche, take a look at something. In the cloud, there are so many different services you can choose from. Okay? There are so many different services you can choose from. And because of that, you can be able to try out different things. In the cloud, because there is elasticity, that gives you the chance to try out different things, and you can be able to innovate, right? You can build things that have never been seen before. Like, look at now, we're using something called ChatGPT. I don't know if you guys know about that, right? We use ChatGPT, and it's really helping us on our jobs. Why? Because it's built on the cloud platform. People, they had those resources available for them. They used those resources to be able to innovate, right? So there is better innovation in the cloud, okay? The fact that there are resources available, and now you can use those resources to try out different things. So there is better room for innovation. Better room for innovation. Better room for innovation. Yeah, thank you, Ate. There is actually high availability, right? There is high availability in the cloud, right? The cloud there's high availability, and that still falls under that aspect of disaster recovery and all those things. Now, one other beautiful thing about cloud is security. Security in the cloud is good. It's top notch, right? Security in the cloud is good. Guys, when we talk about security in the cloud, I was being asked this interview today. I went for an interview. I had 4 security guys on the call. These guys were actually directors of security, director of cloud security, director of cloud enterprise. So they asked me this question. The first question they asked me is, what do I understand? What do I understand cloud security to be? This is how I answered the question. I told them that when it concerns cloud, there is something called security in the cloud, and there is something called security of the cloud. So when you're making use of the cloud platform, there is something called security in the cloud. There is something called security of the cloud. Let me tell you guys something. Cedric and I, we take interviews every day. Every day we take interviews. And the reason why we take interviews is because we want to know the kind of things that they ask so that we can always teach our students. Cloud security is one thing that you're always going to see in interviews. For the past few interviews I've taken, cloud security has been at the top. Now they asked me this question: security in the cloud and security. They asked me what do I consider cloud security to be? I said when we talk about cloud, there is security in the cloud and security of the cloud. Now, what is security of the cloud? security of the cloud, it's talking about that your data, that cloud provider's data center, right, Shampi? It means that the cloud provider is going to take care of security in the cloud. Sorry, security of the cloud, right? So security of the cloud is taken care of by the cloud provider. What does that mean? The cloud provider is in charge of making sure that the data center where those hardware servers are hosted, those data centers are secure. Like the physical security is being taken care of. The hardware servers are taken care of. They are encrypted, they are isolated, and all of that. The physical network is actually being secure. Are you guys seeing? That is simply what security of the cloud is talking about. It's more focused around the things inside of that data center. Shampi, does that make sense? So the cloud provider is taking care of security of the cloud. Now you as a customer, as you make use of cloud services, running in those data centers, you are going to be creating something known as resources. So when you talk about a cloud resource is nothing but anything that is created out of a cloud service. So when you go to the cloud and you use a cloud service, whatsoever thing you create is called a cloud resource. Now, that cloud resource, you need to secure it. Now, we start talking about what? Security in the cloud. So as a cloud engineer, as a cloud architect, security is job zero for you. That means that when you start doing stuff in the cloud, you start from where? You start from security. That's the first thing. You're thinking about securing your AWS accounts. You're thinking about encrypting your data. You have to do that. AWS is not going to do that for you. You're thinking about what? You're thinking about your network, your cloud network. How do you secure that? You have to do that. AWS does not do that for you. You're thinking about securing your servers. You're thinking about securing your databases in the cloud. Your data. AWS is going to provide you services that you can use to secure those things, but AWS is not going to do it for you. That is why you guys are in this class today. The reason why you're learning cloud is because you want to be able to help your company carry out what? Security in the cloud. So security in the cloud is taken care of by the customer. When the customer launches resources out of cloud services, he has to secure them. That is security in the cloud. Now, the cloud provider is in charge of what? Security of the cloud. The data centers, the hardware in those data centers and everything is being taken care of by what? By the cloud provider. Okay, so we are going to continue, I think tomorrow. We're going to continue tomorrow. Thank you guys so much for coming. You can leave your feedbacks about the class. I appreciate you guys coming. And I'll tell you guys that if you want to actually make money, you need to really focus on this thing. Treat it like it's cool. You can see me singing a song here. It's not, I never just learned this in one day. Please do not give up. Do not. Okay? Try to go through class records. All right. And tomorrow we're going to be talking about cloud. We're going to be talking about software 101. Okay? So we're going to talk about software 101 is. So Florence, tomorrow you're going to know what the code is, what the software is, what the software development life cycle is, and all those things. So please come prepared tomorrow. I'll send you guys a list of stuff I want you guys to take a look at.